Hello people, Newbie's back. Took a few days off, went to visit with some relatives, had a great time, but you know what? Traveling, getting back home is one of the best parts. It's good to be back. Anyway, so now we can get back onto the layout and we can try to accomplish something. And what I'm going to talk about today is pretty technical. Could be a little boring for some people. I'm sorry for that. It's also a little jittery. Again, most of it shot with my cell phone. But we're going to talk about controls and control panel. And what I'm going to do to resolve the issues involved with doing a layout control panel. So, here you go. Okay, I got a couple of engines running around the layout just to watch trains run, or at least locomotives. This is the idea of what my control panel is planned to look like. You see that this identifies the block sections by B, 1 through 19, I guess, and the switch turnouts, turnouts number 1 through 40, and they equate to basically what's going on in the layout in terms of all the turnouts and the block sections, and so we'll be able to control the entire layout from a single switch panel. Well, I've started running the wiring through the switches, which I had procrastinated about doing, but you know, you got to get there sometime, and it's just difficult for me to get underneath that layout and actually hook up the wires for those switches and run them all the way back to this area right here where the control panel is going to be located. You see I have terminal blocks here that I have temporarily used for wiring block sections, and so now I have to start wiring the terminal strips for the turnouts, for the remote turnouts. So I've got some COTOs, and I went ahead and temporarily hooked them up to these controllers here. So if you see the engine coming under the tunnel over there, you know, he was running the main line, and I've just switched him off on the side track, and so he'll now come in through the middle of town, and if I flip that switch, then he'll miss the two trains will not come together right there. Well, that was pretty slick. But anyway, so eventually I'll be able to do that by flipping a switch on the control panel instead of manually hitting that switch on the turnout. But the wiring, I've started, like I say, this is the layout, and I started to put together what that control board will look like. And you see here I drilled a bunch of holes in this piece of material. This is actually the what we used for countertops when we built the bar. I had some of this left over, and you see it's basically just thin Formica type stuff. But so I mounted switches, and I got all these wires on the back, and I came to realize that it's going to be about impossible to do that wiring on the back of this. So that's yet to be determined exactly how I'm going to get all that done, but I think I'm going to have to take each one of those switches back off, wire them, and then after I get them wired, put them back on to the control panel itself. And then mount that. The control panel will be mounted right in here. I'll basically just build a frame and mount it there with piano hinges or something so that I can access it, get to the inside of it without creating all kinds of problems for myself. I sure don't want to crawl under. But anyway, that's what's going on right now. You see that I do have, I finished laying the track for the most part in the yard area. I still haven't secured it down, haven't glued it down, and haven't wired the last 4 tracks in the yard there. But for the most part, we're making progress, although when we get to this point, it seems like I spent a lot of time, and it really doesn't appear that I've gotten anything accomplished. But in reality, when you're doing wiring and things like that, it really doesn't show. But the bottom line is that hopefully, once we get it all done and put together and everything is operational, it'll all be worthwhile. Let's talk a little bit more about this control panel I'm designing here, and in particular about the difficulty in wiring something like this. First of all, let's talk about the voltages we're dealing with. The track voltage that I'm using, of course, I'm using a DCC with a power cab, and the voltage on the track is DCC. It's an AC signal, and of course it has one wire going to each of the 2 rails. One that we'll call positive and negative. Of course, they really aren't in AC. Then we have on this console, we have these LED lights. And I did a little experimenting with the LED lights in terms of the brightness that I want from those LEDs, and I've determined that the voltage I want for the LEDs is somewhere around 9 volts. It seems to be about the right illumination level. They can go up to 12, 15, whatever, but I think about 9 volts is the illumination level that I want, so that's kind of what I want to do for those. Then we have the turnouts. The Kato turnouts, I have, I think, 6 Kato turnouts. And the Kato turnouts are basically 2-wire. They're 12 volts DC, plus or minus. And the way it works is that to flip the turnout, what they do is they flip the the polarity of the voltage to the trip solenoids. And so that needs to be wired in such a manner that when you want the turnout to go, for example, from the main line to a junction, off to a junction, then you flip the polarity, and those, by the way, also they're momentary, so it has to be a momentary switch, which, by the way, is what these are. These switches here that I have on the turnouts, these are momentary, and the way they work is that you push down on it and then you let go and it returns back to center. So basically the turnout, if I flip it, you can't really see it too well, but if I push down on this turnout and you let go, you see that it returns back to the center. And that's in either direction. It's kind of hard for me to do here at this, but can you see that? Anyway, see, I flip it and it returns to center. So basically these are momentary turnouts. These turnouts, or these switches to the block sections, though, are not. They're on off. So if I flip it up, it stays up. So the turnout or the switches to the block sections, when I turn a block section on, the amber light will come on showing you that block section is energized. That's simple. So anyway, getting back to the turnouts, the Kato turnouts are 12 volts DC, positive or negative. The Atlas turnouts and the other turnouts that I have are 16 to 18 volts AC, and they're 3-wire. Again, the Kato turnouts are 2-wire. The rest of my turnouts are 3-wire. And those turnouts operate best on 16 to 18 volts AC. So I've got a source for, it's a 16 and a half volt AC source that I'm going to be using for those turnouts. Now, the way those work is they have like I said, they're 3-wire. The middle wire is a common, or a ground, if you will. And the direction of the turnout is determined by sending that 16, 18 volt AC signal to one or the other of the other 2 wires. So there's the 3 wires, and generally are red, green, and black. And if you send you send a 18 volt signal to the red wire, it trips the turnout. If you send it to the green wire, it trips it back the other way. So that's the way those work. Now, you see on my switches here that I have the red and green lights to indicate. So basically what it amounts to is the green lights are the main line as it's going to go around the edge here. If you remember how my layout is working, then it goes around the edge is the main line, and then in the middle is other, if you remember the layout. But anyway, so that's the voltages that I'm dealing with. Now, I mentioned that the turnouts are all, and it's not just the Katos, but the rest of the turnouts, they are all momentary. So you never send a consistent signal or consistent voltage to the turnouts because they'll burn up the motors. So you need these momentary switches to flip the turnouts. And that's fine. But now comes the rub. Now comes the real issue. And that issue is I want to have a green light indicating which way that turnout is. So when I'm on the main line, I want that green light lit. The fact that this is a momentary switch means that I can't wire it the way I wire the block section, because when you turn the block section on, you send power to the block section, and it's very easy this is a double pole, double throw switch. So I can use one side of the switch to run back to the track, telling it to energize that block section, and then I can use the other side of the switch to run 9 volts to my LED, so that when I turn that switch on, it sends power to that particular block section, and at the same time, it sends 9 volts to the LED, lighting the LED. I turn the switch off, and it shuts off the power to the track and turns off the LED. It's different here. When I flip this switch up, it sends the signal to the turnout to flip the turnout, and then it goes back to 0. So there's no source to send voltage to keep that red light lit or the green light lit. That's the issue. Now, in comes a solution. This is what's called an Arduino. This is basically a micro mini computer. And you program this basically using basic language. You can plug it into in my case, I plug it into my laptop and I write code. And so what I'm going to do is I'm going to send a signal through this Arduino. Every time I flip this switch, for example, this is going to be, let's see if I'm 1, 2, 3, 4. I think this is turnout number 5. So I'm going to send a signal from this switch. When I flip this up and let go, it's going to send a signal to my Arduino. And that signal to that Arduino is going to say, hey, turnout number 5 just went to the red mode. And the Arduino is going to track that, and it's going to send that signal to light the light. And how it's going to do that is basically by going to a relay. And the signal from the Arduino will then go to this one of these relay boards. And you see there's relays here, and each one of these is a relay. And so the signal will come from the Arduino to this relay, and it will basically say, relay trip, turn on the red light. And that's how I'm going to do this. And then when you flip the switch back the other way, it's going to say, hey, the Arduino is going to say, turnout number 5 just went green, and it's going to tell this to go back to green. So that's how it's going to work. Now, I have 40, that's 40 turnouts on my layout. That's the plan when I get all these in, that I'll have 40 turnouts. My Arduino board has, I don't remember the exact number, but there's not enough terminals on my Arduino board for 40 signals to go to it. So in order to do exactly what I want to do, I need these, and these are multiplexer boards. And so what these do, and it's actually backwards if you're looking, well, let me move it over here. So a given output from the Arduino, one of these pin connections off the Arduino, one of these pin connections will go into this board here, and it will be multiplied by 4. So by using coding, I can tell a given pin on the Arduino to send a signal to the multiplex board, and that multiplex board then will divide that up and send that signal to a specific one of these 16 outputs. So it's all done, it's a trick, it's done with wires. And then, so that's how I'm going to multiply the output of the Arduinos to be able to control the 40 relays. And you see, I've got relay boards, I've got various different electronic functions here, but that's the way I plan to do this, so that I can keep all of these lights lit when they're supposed to be lit, and it's a little complex. Now, by the way, this is not really that expensive. I think this Arduino board, if I remember correctly, was well, there's a whole kit that comes with breadboards and these little wire plugs and various different electronic components, and I think all together that was like $35, as I remember right. I've had it for some time. And then these relay boards are not expensive. I think 3 of them for, I don't know, $20 or something like that, maybe. Don't quote me on these exact amounts. And then these little multiplex boards, I think I got 10 of these for $10, like $1 a piece or something. So yeah, there's some expense here, but it's really not overwhelming in the cost of doing this. Now the programming is something different. You have to be a little astute in terms of being able to program in Arduino code. But once again, that's just a matter of learning the code and learning how to write the code and just doing it. And there's YouTube videos all over the place about how to code an Arduino. Okay, thanks for sticking with me through that long and tedious and boring discussion. You know, I haven't written the code for the Arduino yet. In Arduino language, it's called a sketch. It's actually C++ code, And once I get around to writing that, and I don't know when that's going to be, but when I get around to writing the code that I'm using, I'll post that down below in the comments section, so that those of you that are interested in seeing what I've come up with, it'll be there for you to download, and hopefully you'll, if you want to try something like this, that'll be a help. Anyway, so that's where we are today, and we're moving right along, and let's see what happens.